Okay, now see, uh, what is the meaning of energy level? Energy level of the nucleus and coupling. Okay, energy level of the nucleus and the coupling. So we have seen, according to molecular orbital theory, we know we are very much aware about the theories of bonding, chemical bonding. One of them is MOT. Molecular orbital theory is one of the theory which is used to construct the chemical bond, or which is used to show the whether the compound is going to form or not. So in MOT, what we do, we write the electronic configuration. We write the electronic energy level, or we can say energy level of electron. We write in that, and what we do, we allow the energy levels of electrons to interact with each other, and then we also learn from MOT that two energy levels, that is called the atomic orbitals, they what they do, they split by combining with each other. They split and they produce new molecular energy levels. So we can say two AOs, atomic orbitals combine and they produce two MOs, molecular energy level. उनको later on we call them as a bonding BMO and ABAMO. हम उसको बाद में बोलते हैं bonding molecular orbitals and anti bonding sigma star sigma, like that. Similarly, we have also the same idea in NMR. So nucleus also considered as a having the energy levels. So when we have a two neighboring nucleus, they also combine with each other and they show splitting. But their combination is called as what? The coupling. Their combination of nucleus called as coupling, and the splitting of signals is called as the what? Splitting. Okay. So when the hydrogen nuclei, two or more hydrogen nucleus, when are near to each other, 1J, 2J, 3J, 4J, up to 4 bond distance. So such nuclei which are near to each other up to 4 bond, their energy levels, they couples which interact, or we can say sense each other. The best word is they sense each other and they split and produce new energy levels, and which appears in the form of signals. Okay. So remember, like electronic energy level, each nucleus have two energy level only. Electrons have more energy levels. We know that electron have more number of energy levels, E0, E1, E2, E3, like that. But nucleus have only two energy levels. We know electrons can be at many places according to energy levels, but nucleus cannot do that. Nucleus either will be low energy level or it goes to high energy level, because only two energy levels are there for the nucleus. Fine. Okay, so what we can say, when such a nucleus, any organic compound, when we take in the NMR tube and we insert that tube in instrument, NMR spectrometer. So what will happen? There we have a magnetic field, strong magnet are working there. So when such a molecule which is under our study or observation, when they comes in the environment of applied magnetic field, so this nuclear energy levels, see these energy levels, they will be either with the magnetic field or they will go against the magnetic field, what we have seen in the last lecture. Okay, so we can see for this, we can see some, see now. See, this is the applied magnetic field, and we are talking this box means inside the spectrophotometer. Instrument में हो रहा है ये. You know this. You should know this. This is taking place where? In the instrument. So this consider this border as an instrument. Instrument के environment में क्या हुआ कि this is the magnetic field created by applied magnetic field, which is inbuilt with the instrument. And see, this nucleus have any nucleus, this is energy level lower and higher. So when the nucleus is aligned with magnetic field, it is at low energy. And we know this is a nucleus, which this spin showing the opposition to this arrow. This arrow shows spin of nucleus, or we can say orientation of the nucleus. So when it is opposing to this, it is goes to the high energy level. So this is what about the proton energy levels. Okay, fine. So now if you see this is the case of cytosine, we are talking about Hx and Ha. See, when there is only one electron, one nucleus, single, so it has only two energy levels because it has no any other energy levels near to it. But when we go for cytosine or like these molecules, so Hx definitely have two energy levels like this. This Ha will also have energy level like this too. But when they interact with each other, this Hx will sense this one. This Ha will sense this one. Now we can say the nuclear energy level, this lower energy level and higher energy level of each one, they sense each other. You're getting the point, guys. Now see, this is the Ha energy level in which the nuclear spin is aligned with the applied field. Therefore, it is lower energy. See, this is aligned with the applied field. Therefore, low energy level. Similarly, this X have this energy, this alignment with the applied field. Therefore, it is also at low energy level. So one possibility is that both the nuclei A and X, Ha and Hx, aligned with the applied magnetic field. Therefore, they are at low energy level. What is another category possibility? Opposite, exactly opposite. So see, you can see here. So is it visible to you? Some of this box is appearing here. So there, what you can see in this box, these two, they're just opposing each other. So we can say both the nuclei here in this box, both the nuclei A and X align against this here, against applied magnetic field. Therefore, they are at higher energy level. So two extreme cases are possible, lowest energy level and one is the highest energy level because of alignment with and alignment against the applied field. Okay. What are the other two factors? Other two possibilities are of if you take combination of these two, like we have taken here and here, both are alignment with, here alignment against applied field. Now see two cases. Let A let A face it applied fields against and let X nucleus aligning with the field. So this is the one case. If you go for this one, let A nucleus or A nuclear energy or A nuclear field or nucleus A align with the applied field while X align against it. See, X is aligned against it. So four cases are there. There are four cases in which we can say the four energy levels are possible. One is this, another is this, and two are, and though, but this is very low difference because there is no much more difference between these two because one is against, one is favor, one is against, one is favor of this applied field. So these two will be same, but their population of this nucleus will be double of these two. जो लोअर एंड हायर में है उनसे ज्यादा पॉपुलेशन किधर है at this energy level. Therefore, three possibilities are there. One lower possibility, then second possibility which is having the more population, and third possibility is this one. Fine. Okay. So see, same. This is the explanation of the same diagram. If you see the cytosine molecule, the proton have another proton. Each proton nucleus feel another sense another proton nucleus. Okay, nearby. Okay, and you see there are four total energy levels. Then see there is only one nucleus, we have two energy levels. When there are two nucleus, we have four energy levels. When there are three nucleus, we can multiply that. No problem. When we have three nucleus, three types of nucleus, the energy level will be according to that. We will see example. So in this case, in this particular case, nucleus Ha and Hx, they can be aligned with the field or they can against the field. We have seen just now. So there are four possible state. So you can see, just I have explained before you. Same thing is here. There is a one most stable energy level where they are both aligned. You see both aligned with the field to most stable energy level, and one least stable is when they are opposite, right? So when they are opposing, they are most unstable energy level. Next point, in between there are two different energy levels. Fine, yes, we have seen now these two different energy levels. Okay, in which one nucleus is aligned with the field and one is against. You see now. In this, you see both the cases. One nucleus against, one aligned. One nucleus aligned with, one is against with applied field. Okay. Okay, fine. So now see, this is the most important sentence from this. Exciting HA from alignment with to alignment against. See, अगर हम HA को excite करेंगे by providing the energy, that is radio wave frequency, from alignment with to the alignment against the applied field can be done in two slightly different ways. Shown A as A1 and A2. You see, this is A1, this is A2. So our aim is to excite this from this to this against this. You see, against this, or excite from this to this against this. In both the cases, you see, in this A and here also A, it is in both with the alignment with the alignment with the, you see, aligned with the, here also aligned with the, this A nucleus is a, according to the orientation of the applied field in both the cases. So we have two options. A1 energy, this going from this alignment with to aligned against with applied field, and A2 is aligned from this A2 energy. What is A2 energy level? Energy required from this for A nucleus going from this aligned with the position to align against. Here you find aligned against this field. So two options are there, two energies. Similarly, the result is the two resonance very close together in the spectrum, and you can see we have seen that spectrum. Okay, no need to go again back to slides. Okay, now next topic, that topic is our next point is how to measure a coupling constant between the molecule, simple molecule, and goes to the complex molecule, including diastereomer, enantiomer, chiral, meso compounds, and many more fused cyclic rings. तो फर्स्ट पॉइंट इज रिकॉग्निशन ऑफ द टाइप ऑफ न्यूक्लियस. पहला जो स्टेप होता है वो ये होता है, हमने जो सीखा है कि हाउ मेनी सेट्स ऑफ प्रोटॉन्स आर देयर. अगर आपका ये वीक है, इफ यू हैव वीक पॉइंट इन दिस concept, so we cannot go for next step. So first point, first decide how many sets of proton. ये पहला एक स्टेप हुआ. सेकंड स्टेप क्या है कि assign the chemical values, chemical shift. Again, this is the second stage. That is very important. We should know the values, the table or chart for the different types of protons, and we have seen that many times in the last previous years, 2 years, third year MSc 1. थर्ड स्टेज जो आता है वो आता ये है कि आइडेंटिफाई द नेबरिंग प्रोटॉन्स, दैट इज कॉल्ड एज कपलिंग कांस्टेंट. कपलिंग ऑफ द न्यूक्लियस बोलते हैं, वो हमने देखा है अभी, हाउ दे कपल्स विद ईच अदर. Fourth stage is what? How to measure the coupling constant. Because without this, we cannot draw the exact structure of the molecule. Exact and absolute are, if there are R configuration, S configuration, we cannot draw this without knowing the coupling constant value. So see how to measure this. Very simple idea I am trying to show you here. The first point you should remember, coupling constant always measure in hertz. Always measure in hertz. What is the meaning of coupling constant? First have a simple idea. Coupling constant कहाँ से आता है? तो याद रखिए, जब neighboring protons, when they sense each other, their nuclear energy goes to higher energy. Due to their opposition alignment with an alignment against the applied field, they have separate energy levels. जितने energy levels रहते हैं न्यूक्लियस के, न्यूक्लियाई के, that much number of energy level will form, simple, and that much number of splitting will take place. We know the Pascal triangle, वो तो आएगा, वो तो theoretical concept है Pascal triangle, but the mechanism is what? Mechanism is very simple. I will show you step one. Confirm that, accept it. Each nucleus has two energy level. Pahla point. Next point. When a nucleus have its one neighboring nucleus, then the total nuclear energy level become 4. Just we have seen. Fine. when we have the two nucleus, when we have the two nucleus, neighboring nucleus two, then the energy level will be four types. Means there are six types, but we can say four types. Okay, एंड लाइक दैट एंड सो ऑन। वो पास्कल ट्रायंगल में हम सीखते हैं, हमको उतना अभी वी हैव नो, हमको उतनी जरूरत नहीं है अभी, हमको समझना है कि एक ही पॉइंट समझना है कि व्हाट इज द मीनिंग ऑफ कपलिंग एंड स्प्लिटिंग, राइट। अब जब स्प्लिटिंग हो गया, व्हेन स्प्लिटिंग टेक्स प्लेस, द सिग्नल स्प्लिट्स, एक सिग्नल स्प्लिट हुआ, टू लाइंस, थ्री लाइंस, फोर लाइंस में, वी कॉल देम डबलेट, ट्रिपलेट, क्वार्टेट। अब वो क्वार्टेट डबलेट का लिंक्स लगाना है, एक मॉलिक्यूल है उसमें चार डबलेट्स मिल रहे हैं, पांच क्वार्टेट्स मिल रहे हैं, तीन ट्रिपलेट्स मिल रहे हैं, हाउ विल यू कनेक्ट द मॉलिक्यूल? if we have a very complex molecule, now you are going to face, very soon we will take examples, very soon. But how we will connect it? If we have three four types of splittings, triplet, doublet, quartet, many things are there, okay, we have plenty of questions, इतने स्पेक्ट्रा है, आप उसको करोगे तो थक जाओगे, तो ये बेसिक आपको जरूरी है, यू आर गेटिंग द पॉइंट। सो हाँ, सो to get the correct structure we should know the coupling constant value, कि वो दो लाइंस जो स्प्लिट हुई है, वो लाइंस के बीच में का डिस्टेंस कितना है, उसको मेजर करते हैं हर्ट्ज में, वी मेजर दैट इन हर्ट्ज। So see, to calculate a coupling constant, it is necessary to be familiar with the ranking of NMR machine in megahertz। तो ये एक अलग कंसेप्ट आया है अभी, हमको मेजर करना है कपलिंग कांस्टेंट इन हर्ट्ज में, ये पहला पॉइंट यू मस्ट रिमेंबर इन माइंड। अब वी सी देर आर रैंकिंग ऑफ मशीन्स वी यूज फॉर NMR, resolution of the compounds, determination of the organic structure, we use different types of machine based on their resolution, simply we can say resolution पर depend होता है। Fine, so we have, in the beginning we had 60 megahertz, then it next go to 90 megahertz, then 120 megahertz, then machines came 20 years ago to 200 megahertz, then it goes to 300 megahertz, in 90s 3 megahertz, then in 2000 after millennium we have a 400 megahertz, after it goes to 500 megahertz, then 600 megahertz, 700, and now today we have 9 megahertz machine. These are the ranking of machines, NMR machines. So you got this? Simple, very simple now. So just I have explained before you the list of machines, 6 megahertz. What is meaning of megahertz? It is nothing but the strength of magnet inbuilt in that machine. Very simple, very simple. You're getting the point? What is the megahertz? What is the why we have a ranking of NMR machines? Very simple concept, because in machines we have inbuilt magnet of different strength, and that strength is called as megahertz, 200, 300, 400, 500, 700, 900, like this. Fine. Now see, therefore when we write the spectrum, any spectrum NMR, when we deal with the problems, you will find 250 megahertz HNMR spectrum, sometimes you find 300 megahertz HNMR spectrum. Okay, sometimes you find following compounds recorded as, one of the compound recorded as 700 megahertz. So you are getting the point. So that is the ranking of machines, resolution. As number increases, resolution increases. Definitely, if you are recording a spectrum of a compound methanol at 60 megahertz, you will get very broad peaks. You see in the Google, you find type the methanol peaks at 60 megahertz. You will say, "अरे सामने दो पहाड़ खड़े हैं," like a very broad peaks will appear. But you know, when you go for the recording of methanol at 300 megahertz, very fine peaks will appear in the spectrum. Very beautiful spectrum would appear before you. You see, okay. Right. So to evaluate the coupling constant, it's denoted by J. This is the most important sentence. Very important. Measure the distance between the lines, the splitted lines. Measure the distance between the lines by a ruler or divider, and use the horizontal scale to find out the separation in ppm. See, I will repeat the sentence. Measure the distance between the lines by a ruler or dividers, and use the horizontal scale to find out the separation in parts per million. Okay, fine. Okay, right? Right. Fine. So then convert these parts per million to megahertz into hertz. Very simple, very simple. See, very simple. You see, measure the distance between the lines by rulers or dividers. We will see after this slide, and use the horizontal scale to find out the separation in part 2. क्या करना है, जो सिग्नल स्प्लिट हो गए स्पेक्ट्रम पर अपेयर हो गए, उसको क्या करना है, वो सिग्नल को आपको मैग्नीफाई करना है. हम देखेंगे कैसा करके हैं वो हम आपको बताएंगे. आई हैव दैट सॉफ्टवेयर, डोंट वरी. कैम ड्रॉ कहते हैं उसे. और वी कैन मेजर द वैल्यू डिस्टेंस बिटवीन द लाइंस. वी कैन मेजर इट, फाइन. वी कैन मेजर इट, फाइन. हम आपको बताएंगे कैसा मेजर करते हैं, फाइन. एंड देन कन्वर्ट द दिस पीपीएम पार्ट्स पर मिलियन टू मेगाहर्ट्ज इनटू हर्ट्ज. फॉर एग्जांपल, वेरी सिंपल. अगर कोई मशीन 300 मेगाहर्ट्ज पे है, 300 मेगाहर्ट्ज पे है, तो 1 पीपीएम कितना होता है, 300 के बराबर होता है. अगर कोई मशीन 300 मेगाहर्ट्ज की यूज कर रहे हैं हम, तो 1 पार्ट पर मिलियन कितना होता है, ये आप एक मोटा मोटा याद रखिए, सिंपल. अगर कोई मशीन 90 मेगाहर्ट्ज पे है, तो 1 पीपीएम यानी क्या होगा, वो 90 हर्ट्ज होगा. ठीक है, याद रखिए, याद रखिए. और 1 पीपीएम कितना होता है, ये देखिए बताते हैं. You see this example. So I have original also, but let us have this again. I will show that. ये molecule है. This is not much more interested for us. See, I am just trying to show you. You see this aromatic signals. You know aromatic signal. ये आपको box दिखाई दे रहा है, सामने appear हो रहा है क्या सबके? ये this box. Sorry.
हाँ सर, सबके सामने appear हो रहा है.
हाँ, उसको थोड़ा problem 1 minute. Fine. Okay. So now see, you see this you see how many sets from this aromatic ring? Can you tell anyone? कोई बता सकता है? How many sets from aromatic ring? Yes. बोलिए. वहाँ कलर दिख रहा है, कलर दिख रहे हैं ना आपको, colored hydrogens are there. How many sets you are expecting? 2 sets. One is for this red, another is for this, right, orange color hydrogens, right? Yes. So these two are same, these two are same, and but these two are not same, therefore they sense each other, they couple each other, and they split as a n+1 by a rule, doublet. So you see this 8.8 hertz appears as a
not seen in sense of the environment surrounding it, right?
see this hydrogen is there, ये दिखाई दे रहा है आपको, right?
Yes.
This hydrogen and this proton, are they same? They are not same. See, what I said.
No sir.
We have learned this. I am not trying to asking you how many sets of proton. That is over. We will not go for that again. I am just trying to tell you that is by default it is understood that we know this. How many sets are there? Our target is this proton coupling with this proton and this coupling with this. Fine. And they are appearing where? On this region, in this region, the aromatic region. So now you see this carbonyl is here and methoxy is here. Which is the electron withdrawing group? This carbonyl is electron withdrawing group and methoxy electron withdrawing group.
Carbonyl.
Yes, very good. So which will appear at higher value? This H or this H? Yes. This H or this H? Red or
carbonyl
orange?
के बाजू वाला.
Orange.
Very good.
The
Very good.
carbon.
Very nice.
Yeah,
That's correct. That's correct. So this proton will couple with this and n+1 rule से क्या होगा? Doublet आया. देखिए ये अपने doublet, right? What? Yes. What is this 12.3 hertz? What is this peak? That is of what? बोल सकते हैं आप में से कोई? What is that peak? That peak of that peak. What is this peak? Okay. ठीक है, that we will not focus that, हम ये लेते हैं, वो ज़्यादा discussion हो जाएगा. Now let us see what is the meaning of 1 ppm and what is the meaning of coupling constant value. We will take two points. Now see, this couple with this and doublet. So ये जो distance है, this distance between these two lines, distance between these two lines is called as coupling constant. Okay. Now let's say next point is we are measuring the coupling constant for this hydrogen. This also coupled with this, and this will appear here, and it is called as what, the doublet, and this is here. Okay, ये distance is called as coupling constant, this distance is called as coupling constant. Okay, now you tell this 1 ppm means what. You see 4 to 5 is called as 1 ppm, that is equal to 90 hertz. सुनिए, this is called as 5 to 6 is called as 1 ppm, that is equal to 90 hertz. Why 90 hertz? Because this instrument is of 90 megahertz. समझा क्या? Yes. ठीक है? Yes. Next point. Here you see, if you see this 7 to 8, this is also 1 ppm, that is called as 90 megahertz. यहाँ से यहाँ 90 megahertz होगा, यहाँ से यहाँ 90 में कोई भी कोई भी दो नंबर का जो डिस्टेंस है वो 90 मेगाहर्ट्ज होगा. इफ यू सी दिस वन, ये एक मॉलिक्यूल के वी हैव टू स्पेक्ट्रा. if you are recorded this at 90 megahertz, so it's 90 megahertz. अगर if this is recorded as 300 megahertz, तो ये यहाँ से डिस्टेंस कितना होगा बोलिए? what is the distance from here to here? 300 hertz. Okay, so it is a very basic idea that the ranking of machine will tell you 1 ppm meaning how many hertz. Next point, what is the value of this j? So if you take a scale and you put horizontal, this distance will tells you about the this distance will tells you the exact value of coupling constant j, and we measure this into hertz. So now see, आप देखिए यहाँ पर ये यहाँ से यहाँ तक कितना है? 12.3 हर्ट्ज. एक्चुअली दिस स्केल पर ठीक से नहीं बताया गया है. ये यहाँ से यहाँ तक कितना है? 12.3 हर्ट्ज, एंड दिस टू दिस इट इज 12.3 हर्ट्ज, एंड ये जो डिस्टेंस है दोनों के बीच का, दिस इज कॉल्ड एज 8.8 hertz. 8.8 hertz. This distance is called as 8.8 hertz. So we can say this couple with this and split. How? What is the distance between the two lines? 8.8 hertz. और ये जब इससे कपल होता है, what is the distance? 8.8 hertz. तो यहाँ पर एक concept clear ऐसा होता है कि when two neighboring protons they are coupling with each other, when two neighboring protons they couples with each other, their coupling constant value is same. You're getting the point? Yes. When two neighboring protons they are coupling with each other, their what? Their coupling constant J value is same. And on the basis of this coupling constant, we can connect them. See, it's a very simple molecule. So एक यहाँ मिला है, एक यहाँ मिला है. अगर एक यहाँ होता, एक और कहीं होता, so we can connect them. No problem in the molecule now. See, same molecule when we are running on 300 megahertz. So you see at 90 megahertz distance is more. दिख रहा है आपको ज्यादा मैग्नीफाइड लग रहा है, लेकिन 300 पे सेम रहेगा. देखो एक छोटा सा हो गया है ना गैप, दिख रहा है? Yes.
Yes, sir.
But what is the value? Value is fixed. That is called as constant. So what is the statement? J value is independent on the what? J value is independent on the rank of, or what is when applied, what do we say? J value is independent on the applied magnetic field. J value always same. You take any molecule and measure in any instrument, J value will not change. This distance, which is very magnified here, would be shrink or become very sharp, but still it will give you value that is 8.8 hertz. Here they are same. Okay, so now let us go for again. If you look for further things, HA and HX proton, like we have seen in the cytosine. So, and we consider that there is no interaction, though there is no sensing, or there is no coupling between the protons. So they will appear like this. Fine. हम इसको और समझने की कोशिश कर रहे हैं. Video will stop in 1 minute, so आपको rejoin करना है. See. So you see this spectrum without sensing of each other energy levels. ठीक है? But we don't see such a spectrum in the for the cytosine. हमको ऐसा नहीं मिलता है. 7.